So 6-2 is applications of normal distributions, and this is a really nice thing because sometimes when they give you information, not everything's going to be as easy as find the z-score, go to the table, or go to the calculator, plug it in, that's your answer, you're done. Not everything's going to be like that. And so what if they don't give you a z-score? How do you find the probability? How do you find that area underneath the curve? Well, it's actually very simple because there is a formula that you can use to get your answer. So if they don't give you a z-score, the first thing you have to do is you have to use the formula. And I'll write the formula for you. The formula is your z-score will equal your value minus your mean, all of that over your standard deviation. Standard deviation. And so we can do shortcuts. Our value could be x, our mean is going to be mu, and then our standard deviation is going to be that little o. After you plug it into the calculator, which this formula is super duper important with, you just found your z-score from that, and then you use the table. And the table, again, is on, for us, it's page 779. All right, and so as long as we have this formula down pat, we can do whatever we need to do to convert any information they give us into usable data. So let's look at an example. Example 1 says adults average 5.2 liters of blood in their body. Assume it is normally distributed with a standard deviation of 0.3, and find the percentage of those who have less than 5.4 liters in their body. So when you're doing your homework, please make sure that you're not like, I don't need the whole paragraph. That's not necessary. Just writing down key pieces of information like the average is 5.2 liters, our standard deviation is 0.3 liters, and we need to find things that are less than 5.4. So if I were to draw the picture, it looks something like this. Here's 5.4, and I'm looking for everything less than that. So everything to the left, which is perfect because my z-score table gives me the area underneath the curve to the left. Okay, so that's really, really important. But we can't do the z-score yet because we don't have the z-score. We got to convert it. So we're going to use that formula, which is the value minus mu over standard deviation. And we're going to plug things in. 5.4 is my data piece that they gave me. They said the average was 5.2, and we get a standard deviation of 0.3. And then from here, I go to my calculator. So I can't exactly put the calculator like on here, but I will tell you what all my calculations are. First things first, I'm going to subtract the two numbers in my numerator, which is going to give me 0.2 over 0.3. And finally, I'll divide by that 0.3, and I will get 0.66666. And obviously, like, I can't have infinitely many sixes. So we're just going to round to 2 decimal places, which makes sense because the z-score table only includes 2 decimal places. So now that we have our 2 things, this is our z-score, but this is not our answer because it's not asking for the z-score. It says find the percentage. So that means we're going to have to use the z-score now and get our percentage or our probability. So if you're using the table, you can just go to page, I think it's 780, because that's where the positive z-scores are. And you can just find on the table the 0.6 and then look for that 0.07 and, figure out where do they intersect, and that's going to be your answer. Or you can use the calculator, which is what I'm going to use because I don't have the table with me. So I'm going to go to second VARS, and it gives me some information, distributions, and drawing. I'm going to go to number 2, which says normal CDF. And I have technically it's like negative infinity over here, so that's my lower bound. So I remember, if you're doing that, it's negative 1e to the 99th. So basically it's basically like a really, really small number in scientific notation. But my upper is going to be 0.67. Press enter a whole bunch of times, and your calculator should give you the answer of 0.7486. 0.86. It rounds to that. And so if we turn this into a percentage, it's 74.86%. And that is our answer. So we have just used our formula here to find our z-score. And then we use the z-score to get our final answer. All right, so it's going to be the same process no matter what type of problem we get now. So let's go to the next problem. Example 2, each month Americans generate an average of 28 pounds of newspaper garbage as either recycling or garbage. Assume it is normally distributed with a standard deviation of 2 pounds. All right, so I have my average and I have my standard deviation, and it says find the probability of these two items. So if you're using the table, please remember that when you have two values, you actually have to subtract them. You find the z-scores of each one, then you find the probability of each one, and then you just subtract the two. Again, I'm using the calculator, so I don't have to worry about that. But if you are using the table, just remember you find the z-score, that gives you your percentage, which should be, a bunch of like numbers. And then you subtract the two, and that's going to be your answer. All right. So we'll go ahead and we'll use our formula. We'll erase all this, which is, beautiful, but we'll erase it. And we'll plug it in for each one. So we'll do 27 minus my average, which was 28, over 2, which is going to give me 0.5. And then we'll do the same thing again, 31 minus 28, which is going to give me 1.5. Or actually, this is not positive 0.5. This is actually negative 0.5. My bad. And the other one's positive. Perfect. All right, so now I'll go to my calculator. Second VARS. I'm going to press number 2 for the normal CDF. My lower is going to be the smaller of the two z-scores. So that's going to be negative 0.5. Enter your upper one now, which is 1.5. Press enter a bunch of times, and you should get the answer of 0.6247. All right, and this is find the probability, and probability can be either percentage or decimal, and I'm going to keep mine a decimal. All right, and then finally we're going to do more than 30.2. Now, in the table, it gives you everything to the left, which is less than, but now we're doing more than, okay? So that's going to go off to the right now, 30.2. And so this is the one where if you're using the table, you're going to say, all right, we found our z-score, which gives us our z-score, and that's going to give us our probability. And then once you're done with that, you're going to say 1 minus the probability, okay? And then that's going to give you your answer, okay? So that's what you need to do for this. But again, I'm going to use the calculator. I know you probably don't have a calculator with you, so using the table is definitely possible, or should be possible at least. And if you don't have the table, it's online for you. Just type in z-score table. So I'm using that calculator, and I am going to plug it into my formula first. 30.2 minus my average, which is 28. All of that over 2. So 30.2 minus 28. That's going to give me a 2.2 divided by 2. And I should get 1.1. All right. So I got this. It's all beautiful. But again, this is not my answer. This is my z-score. Z-score gives me my probability. So I can go to the calculator. And if I'm using the calculator, I can actually set it up, so that is my lower bound, and my upper bound is just positive infinity. But just for sake of, having similar processes with you guys who are probably using your book or a z-score like handout or online worksheet, whatever, I'm going to actually just do it like normal and find the probability and then subtract from 1. So if I plug in, oops, wrong one, hold on. The lower is negative infinity. 1.1 is my upper. Press enter a bunch of times. And again, you should get the same thing on your end, but if you go to the table, you should get 0.8643. And so this is the probability to the left. But if you look at our picture over here, we need to find it to the right. And so to figure that out, we're going to say 1 minus 0.8643. So if I get that, it should give me, let's say 1 minus 0.8643 should give me 0.1357. And again, probability can be written as either percentage or a decimal, but I'm going to leave it as a decimal. And I want to keep it as a decimal just so that you can see that sometimes they're going to ask you for the percentage or for the probability, or in the next one, they're actually just going to ask us to find the number of times that this happens. And the purpose of that is to just show you that no matter how they ask you the question, your process is always going to be the same. You take your value, you plug it into the formula, you find the z-score, and then you find the probability, or you find the number of times it happens. So let's look at this next one. Example 3 says on an average decibel of a concert is 120 decibels. Decibels, it can be written as dB. Assume it is normally distributed with a standard deviation of 6 and find the number of concerts that are less than 112 decibels. And there's another piece of information that I didn't mention, and that is they tell us that we got this information from 100 concerts. And so the reason they're telling us that they got this from 100 concerts is so that when we answer the question, find the number of concerts, it's going to be the same, it's going to be equal amount as our probability, because remember, if the probability can only go up to 1 or 100%, and 100% is the same number as 100 concerts. So they're telling us this so that we know that once we find our answer, our probability, that probability is actually the same number as our concerts. And so that's the whole purpose of this question. But it doesn't really matter because it is the same exact process. I have my average, which is 120. I have my standard deviation, which is 6. And then I have my x value, which is 112. And it says less than, so I know it's just going to be straightforward. I don't have to subtract anything. I don't need to say 1 minus anything. I just go to my table, I look at it, I get my answer. But I got to plug it into the formula. So it'd be 112 minus 120 over 6. And I do the numerator first, 112 minus 120. That's going to give me a negative 8 divided by 6, which is going to give me a negative 1.33. Technically 3 repeating, but again, the z-score table only goes to 2 decimal places. So for you guys, you're going to go to the table. For me, I'm going to go to my calculator. I'm going to type in my lower bound, which is negative infinity, and my upper bound is negative 1.33. And then I press enter a bunch of times. And I should get a probability of 0.0918, okay? And so if I were to turn this into a percentage, it's 9.18%. Because remember, you move your decimal 2 times, so it would be right there. Okay, but remember, that piece of information that I didn't tell you before is there's 100 concerts. And so 9% is out of 100. So how many concerts have less than 112 decibels? Well, about 9 concerts. Okay, and so this gets you to your homework, which is, let me look that up. All right, so I finally found it. It's the 6-2 exercises, numbers 1 through 3, and then 5 through 8 all. Okay, so it's all of these, a total of 7 problems. Again, you don't have to write down the entire problem, just write down the key bits of information, such as the mean, the value, and then the standard deviation. Plug it into the formula, and then go from there.